Great, and we're live. Today we're doing reverse engineering of the famous Gravis Ultrasound. So right now I'm placing parts and footprints and slowly working my way through the schematic. And since, it's something that's going to take a while, I'm just going to kind of go through it a little bit at a time. I figured I'd probably do this on stream so that other people doing other repetitive tasks can join in as well. So it's sort of one of those co-working type situations here. So I'm going to do a little bit off screen on the schematic and get right back to this guy. R8 looks like the next one is R9. Is that 0 ohms? I can't really tell, but I do have better pictures of it, so we'll try and figure that one out. So R9 is next. And where is R9 physically? We'll give that a question mark for now. And I should probably also put in the capacitor, which is C16. Oh, yeah, sure enough, C16 is the next one. Let's go ahead and update and place these. So that's R9. That is C16. Okay, so it looks like pin 1 goes to the plus terminal here. So we'll go ahead and connect those together, and then it looks like pin 2 goes to pin 2 of this op amp. And that is, which one is that? U4. Okay, so let's move that around. I'm working on the schematic here, but things will probably light up a little bit on the layout for cross probing. Okay, and then there's a C17 and an R10. And that's probably just the feedback capacitor and resistor. So I'll go ahead and place those. Let's rearrange that a little bit. Sorry about working off screen, but I want to try and get this going here. So you'll see those two components pop up in a minute. Okay, let's propagate this to the layout, and we'll get two more components. Now what's interesting is that these components, the designators are not sorted by physical location on the circuit board, which means that the designators are ordered as they appear on the schematic. And that can be useful for coming up with a schematic that matches kind of the original. So even though I don't have the original, I can still kind of figure out how that's supposed to work. And so yeah, that wire is going to go over here. I'll probably have to start adding traces at some point. So that's R10 and C17. And let's see where the next one is. So there's an R11 over here and a C19. C18 over here. Okay, so that's going to be the next couple. And this component here, so there's a test point, and then I guess that's R15. So I'm not sure where these go, but I guess I'll try and add those in. This is the Advanced Gravis Ultrasound Plug-and-Play version 1.0. So it's a very specific version. Mostly this is a card that I got in for repair, but it had a lot of damage, and like most of these parts here were already missing. And so I figured I'd just take it down the rest of the way to a bare board and reverse engineer it while I was at it. So actually, maybe I should start routing some traces here. So maybe we'll do a 10 mil. Although actually I should just measure this since I'm here. So we have a 10 mil grid. Let's do a 1 mil grid and then just do a couple quick spot checks here. Okay, so that says 14. It's probably a 12 mil trace. Actually, it could be 10, but it's probably 12. Yeah, call it 12. So let's edit that. And then I'll need to figure out vias, because I think there's some vias in here as well. So that's a test point. That's not a via. These guys are vias. And the drill looks a little big on that. So let's figure out what this is. That's probably 40 and 19 or 20. Yeah, so let's go ahead and create some vias. Oops, that should be 20. I think that's right. Technically, I should be using the default net class and editing that, but I can do that later. It's not a big deal. So let's go ahead and start routing some traces. First, I need a better grid. I'm guessing it's probably 10 mils. That's probably a pretty good approximation of the original. And for some reason that didn't work. Do I need to flip this around? I need to flip this around. Let's do that. And these guys, I'll have to do the test points eventually. Yeah, and that goes elsewhere. We'll figure that out. Oh yeah, I should do these power traces too. $50? Yeah, that's probably 50 mils. Save early, save often. 6 viewers is pretty good for not announcing this on social media yet. Maybe I'll do that at some point. So let's do 50 and see how well that lines up. Okay, not bad. Not bad. Except I got this wrong in schematic. So let me try and match this up. Yeah, interesting. I thought that was in series, but apparently it isn't. So we'll need to figure out where that goes at some point. And that just comes down and around and into that capacitor. This does not have to be a perfect match. This is basically going to be used for repairing the board. So I want to get an idea of where each component is in the schematic. So if I have to choose a new value, then I can choose something with actual engineering judgment. So that's 20 mils. And this is an old enough board. These are probably all just powers of 10. Or factors of 10, I should say. Okay, so we've got C2 going to pin 5. I don't know what the heck that is. That'll probably take some more work to figure out. Ferrite bead, that goes to a via. I'll figure that out later. This will be a polygon pour with a via. But I guess I can do some of this stuff here. And that goes over here. And that goes to a via. Yeah, I should probably do the polygon pour next, but I don't even know what net that is. C4 pad 2, fine. C4 pad 2, 10 and 20, could be. Gap and spoke, could be. I might have to change that. The grid seems to be about right. Yeah, again, I'm assuming that whoever did this board layout used some super ancient software by today's standards, and so they're going to use the grid in a pretty disciplined way. So that seems pretty close, so I'll just leave it at that for now. Let me catch up with the chat here, and because folks have some questions. K. Dell says I did a reverse engineering of the Gus PNP based on very low resolution images that Gusar cloned a few years ago. Is that the same card? If so, I can share the project if that helps. I think I'm actually in pretty good shape here. Yeah, I'm going to give this a try, and then I guess I could bug you if I run into issues. But honestly, I don't think so. I don't think I'm going to have any difficulty with this. I might need photos of a real card, but somebody contacted me on Mastodon, and they have access to a card, so that will be very helpful. That one looks like a 50 mil. Yeah, this is all just the voltage regulator section here. So I'm just sort of taking care of stuff that I've already netted out. You know, I'm not sure that's still 50. Some of this might actually be narrower than that. Might be 40. Let's set the grid down to 1 mil. And I'll just do a quick measurement across here. 43. Yeah, that's probably 40. I'll take one more measurement just to be sure. Yeah, 40 mils. So we'll add another size here. 40 mils. And let's go ahead and route that. Yeah, see, 50 is just a little bit big. I got to turn that off. And let's go back to the old grid. Yeah, that makes more sense. Okay, and then that also tells me the connection between these two capacitors here. Presumably that is ground, because I can already see this thing taking shape on schematic. I'm hooking it up in a way that makes sense. So this is good. So that's coming together. Obviously we've got some parts for bypass capacitors on these op amps. Ah, look at the time. And there's R14. I don't know if I've done R14 yet. So that's R10. So I guess naturally R11 would be next, but that's way over here. So I guess I could do that. And it looks like there's a C26. That's interesting. That might have been added later. You can do a little bit of schematic forensics, because typically the higher numbers are added later. And then that goes to a C19 negative terminal. So I'm just drawing that out on the schematic, and then I'll propagate it here and see where it goes. Yeah, so here's C19. R11 goes here. Oh, I might have mixed up the capacitors. Yeah, sometimes it's a little hard to tell where the designators go. By the way, this is not meant to be an exact clone of the card. It's mostly for repair information. Okay, so that's C18. So this is actually C18. So let's go ahead and save that. And then I'll move that over. Yeah, that makes sense. Okay, so C18. So an exact clone, I would redo the footprints to match this card, but that's not really the goal here. And then the plus side goes to, presumably this is R15, and that's a larger footprint, so I'm going to have to go up one size there. And R15 goes to pin 1, so this is actually on the output of that op-amp circuit that I just started laying out. So let's do that. R15, and I think that's a 1206. So I'm just going to pick 1206 and we'll see how close that ends up being. There's our 15. Oh, look at that, very close. And we'll put that here. That actually looks like a 20 mil, presumably to, well, I don't know where this is going. And then that will be back down to 12. Good. Go ahead and save that. Next up we have, presumably this is very much a similar circuit, just off of the other op amp on that same chip. Would we not use the grid in a disciplined way now? No, we do not. We do not use grids in disciplined ways. It's just not how people do it nowadays. It's whatever random ass smart grid Altium comes up with. So it's functional, it just kind of offends my OCD nature. Okay, so that's going to be R12 and C27. So presumably that is another network off of, gosh, what is that, pin 7? 1, 2, 3. That's going to be pin 7, so that's going to be this other op amp. So I'm just going to duplicate this whole mess and reassign designators. So this will be R16, C19, R12, and C27. Perfect. Okay, so let's go ahead and update that. And this will be, presumably, these are stereo, so it's like left and right channels. Yep. I need to figure out how to lock images, but unfortunately they don't show up as a separate object here. I mean, I can turn off graphics, but then I can't move anything that's, well, hold on a minute. Oh, I see. This goes here. I was going to talk about why I'm not doing a super thorough job on getting this pixel perfect. And the reason is that this is not a card that's easy to replicate because it's got this full custom chip here that they call the Amadeus AM78C201 or whatever that is. And so all the existing clones of the ultrasound have to like basically replicate its functionality in some other way. So this isn't really a clone in that sense. All right, so this will go up and around. Okay, so that's going to be our line out. And then presumably this is going to go to ground or something. So that's R12 and C27. So that's probably an output filter. So I'm going to rearrange things a little bit on the other screen here. So I'm just assuming that's going to ground. So these op amps are all going to be buffers for the inputs and outputs, I'm assuming. So it's the R values are probably important. The capacitor values may not be all that critical. So they're just going to set filter coefficients and stuff, but yeah, we'll see. And then that'll split off and go to the feedback network. This all makes sense once you see the schematic. So let's go ahead and move that around. I'm going to have to move my voltage regulators out of the way. Yeah, I don't think the circuit's going to be all that complicated. Okay, so we need C20 and R13. In fact, let me just copy this whole thing here. Let's update that. And then at some point I'm going to have to figure out what the values are supposed to be. The good news is that since both channels are going to be the same, it should make things a little easier. Okay, so you can see I already mixed up pins 1 and pins 2, so I'll have to go fix that. Great. Ta-da! And then this will come up and around. And that's R14 and C something or other. C21? Sure enough, C21. Go ahead and update that. Oops, one too far. R14, C21. Yeah, this card was really shredded when I got it, and I think it probably popped out of an e-waste computer and somebody tore it out with pliers or something. And that'll go up here, and then this guy goes elsewhere. So we'll have to figure out where that comes from. Same thing with the other channel, but presumably they disappear into that chip. Oh, I should wire up all this stuff too. Oh, of course I switched these up. Okay, let's try that. Wow, I really got that wrong. So R3 goes to what's presumably a power rail. Maybe ground. I'm going to rearrange the schematic a little bit. Oh, that might be a divider. And we're rotating it back. That part's correct. And this goes out here to the line in. And that also goes to the line in, but to the other channel. Goes down there. And that'll go up and around to the other capacitor. And then these two resistors are wired together. Let me straighten things out a little bit over here quick. That's probably ground. And then the input goes somewhere. And then we have a little test point, which I'll probably have to add at some point. TP17, huh? Great. So that is the line in. What's next? We have C21 is done. 24, 23, 24, and 25. What am I missing? There's 22. I don't know where that goes. So we'll just add that and leave it unconnected for now. It's probably going to some internal power planes or something. Oh yeah, did I mention this is a 4-layer board? So that'll be extra fun to figure out. And then the next couple of connections are the power connections for this op amp and the filtering that they've got on it. So that's pin 8. And then presumably pin 5 goes to the other pin of C2. So pin 5 is probably tied internally to something. And then up here we have pin 4 going to C24 and C25. I got to check the polarity. Plus is up here, so the negative is going into the pin. That makes sense. And then 25 is going to be another ceramic. All right, and a bunch of parts up here. Let's put these in. There's C23. And C24, C25. Oops. Great. Let's hook up a few wires. This will be 20 mils. This will be presumably 40. Probably the same thing here. That might be ground, but who knows. Yeah, what is pin 5? Oh, that's the plus terminal of the op amp. So pin 3 and 5, I don't really see much of a connection there, so that'll be fun. We'll have to figure that out. Okay. TP9, I'll have to add test points in there. By the way, you can see the shadow of the various power and ground planes here. So at some point I'll add more layers and then start adding those in. Yeah, presumably this is for noise reduction or something. And let's get a thicker trace here. You can also see that these components were like ripped off the board. So I think this was someone's parts board, but I don't know how these parts got removed. It's very strange. Like you could just see the cracked ends of the lead here, and like clearly it was not desoldered, so I don't know what the story is with that. Oh yeah, we got some diodes. That looks like a protection diode for something. So I'll have to figure that one out. All right, so what comes next? So I've got these two op amps done. And where do these go? Not shown. this goes to the J3 line out. So let me go and add that part in. Line out. That would be T. And that'll be the next connector. It's not a perfect match in the footprint, but who cares? It's fine. And then presumably this trace is on the other layer, so we'll worry about that later. Okay. So we have, looks like C25. Where's the next capacitor? These are all like 61, 62, 63. Suppose I could always skip, but R44, C100. Yeah, these are all pretty high up there. C57. Yeah, I'm not surprised if the bypass capacitors are last. So here's C28, 38, 33, 35, 34, 37. Oh, here's C30, C29. That might be the next one. C28, it thinks. Is there a C28 somewhere? Yeah, the order is interesting. I'm not sure why they did it that way, but that'll be the order that the original schematic uses. So there's C30, C29. Yeah, I don't see it. But the resistors here are also next there. It is C28. Got it. Okay. So I think I should get the joystick port in there. So that will be a female 15 pin D sub connector. So that'll be a DA15. And that should also have mounting holes on it. Okay. I should assign that a footprint. I am going backwards from the PCB to the schematic because I couldn't find a schematic. And what's the offset of the pins? It's like a couple of different styles of connector. This one's probably the closest. It's not great, but it'll be fine. And this will be P1 called MIDI joystick. So let's go ahead and pull that component in and place it on the schematic. Oh yeah, mounting holes are in the wrong spot. Whatever, it's all good. So it looks like pin 1 and 9 are shorted together. So that's fun. So that's C28, and then that goes to a via. Then there's a C36. That's probably ground. And then we've got C29 down here, and a bunch of resistors and a resistor array, and then some ferrite beads. 4, 5, 6, and 7. All right, so I should probably figure out those next, because then those go into the resistor array. Oh, that'll be fun to figure out. 1, 2, 3, 4, 5, 6, 7, 8 pins. Yeah, that'll be interesting. So this is all part of the joystick circuit. Connectors are never correct. Okay. Let's get some ferrite beads in here. I think I already did a couple. Yeah, they're the same footprint, looks like. I bet you they're the same bead. It's cheaper that way. So this will be 4. Actually, I'm going to rearrange things just a slight bit. So FB4 goes to pin 3. And then 5 goes to pin 6. And the other two I don't know. Let's go ahead and pull them in. Yeah, these look like joystick filters or something. And I have a cracked remnant of part of one, so I might even be able to get a good measurement off of it, because presumably the others are all the same device. But if not, it's not a big deal. These are just for EMI, and like nobody cares about that. Not for sort of hobby repair like this thing. Yeah, let's do pin 1 on this side. Okay, I think it might be time to route this and then take a look at the bottom layer and see if there's anything interesting to be seen. So there's actually vias here. And then we got a bunch of caps, resistors, all that silly stuff. All right, let's have a look at the bottom layer. Why is there no image here? I must have deleted it by accident. Or maybe I never put it in. You know what? I think I got ahead of myself and never put it in. So let's go ahead and do that. Place reference images. There's our bottom layer. Come on, you're supposed to snap to it. All right, we'll have to do coordinates then. Oh, graphics, that's why. Maybe not. All right. There's our bottom layer. Let's see what I can do. Oh, I did not expect where that was going to go. So we'll go ahead and draw those in. So 12 mil and 10 mil centers actually explains why the traces look so weird on the bottom. Like they're kind of extra fat, but then the distance between them is really narrow. So that's just the grid and then the size of the traces. 20 mil, I guess. So then we can go ahead and follow these. Doesn't have to be perfect. So that is going to be FP6 goes to pin 11. And FP7 goes to another via. Good stuff. That goes to 13. And there it is. Great. Now we need to do the resistor array and then the resistors. Unfortunately, my card did not come with the resistor array, so it was one of the things that was removed. I think someone used this as a parts card for some reason. Okay. Yeah, I wonder if those are series or if it's just a... that's interesting. So it goes out through here, and then we've got a resistor, and then a capacitor. But then this resistor here... That goes elsewhere. That guy goes here. That guy goes here. Here. I don't see anything that looks like a pull-up. Yeah, and this doesn't go anywhere else in the bottom, so I think these are probably just individual resistors. I guess I'll just try it and see what it looks like. So we'll do a resistor array and then go from there. That'll be an RPAC, resistor, our network. That's what I was looking for. That's 4 of them. That'll be network force split, I think. No, that's not right. It's not network dividers. R_pack, so that was correct. RPAC split. Okay, I think I found it. So that should actually be RP1. Instead of RN1. RP1. And I don't know what value that is yet. Okay, so pin 2 looks like it goes to this ferrite bead. Excuse me. And then 3 goes to this one's pin 2. I'm just doing a little schematic work to try and keep this nice and neat. And then the next one, 1, 2, 3, 4. Okay, so 5. That goes here. 5 and 6, and then I guess 7 goes to the remaining one. So let's do that one real quick. Oh, there it is. And then let's put it in. Yeah, I think I got the grid correct. That looks really nice. There and there. And now we need to get these resistors in too. Oh, wait a minute here. So one goes elsewhere. Pin 2. Oh. These resistors are just wired across. That's weird. Why would they do that? That's a mystery. Oh, I think I know what's going on here. These are stuffing options. So all of these resistors here, they've never had any resistors installed, only the resistor array. So you pick one or the other depending on whatever you have in stock. So that's actually kind of neat. I'm doing a little bit of schematic work here to make room. But let's go ahead and get some of those resistors in now. So the next one on my list is R17. I don't know if that's what should go here. So I might have to skip some. Oh, R17 is down here. And that just goes to a capacitor and pin 12. Yeah, this is just all resistor networks and such. And there it goes. So that's R17. And there's a bunch of other parts down here. Capacitors, there's R18, which goes to pin 15. So let's go ahead and put that one in. Yeah, this design is pretty much fully integrated. So basically all these wires are just going to go and disappear into that main chip. So good for cost savings, I bet. So that's R18. Is there an R19 anywhere here? We have 20, 21, 22, and 23. But I don't see R19. See, these are all capacitors here. So R19 is presumably elsewhere. Or it got deleted. Oh, here's R19. I wonder what the story is there. Well, let's just place it. And I have a funny feeling it is attached to the joystick port. So let's try that. So I'm just going to place it and then follow the trace and see where it goes. And we'll just follow this. There's a via here. We'll have to follow that on the other side of the board. But then it also continues along. See, this is much easier than trying to follow it in like Inkscape or some other drawing program, because you're also creating a trace at the same time. So this is much faster than the old techniques that I've used in the past for reverse engineering. Okay, so it looks like it's actually just attached to R17. So that's interesting. I wonder what the story is with that. But I think the answer has to do with this via over here. And of course there's a test point. Let's see where that goes. Goes up here. And back to the top layer. And I bet it disappears into a pin. Sure enough, there's a pin. And that goes to a plane. So I bet you that's either a pull up or a pull down. But the good news is that's R19. And now we've got R20, 21, 22, and 23, which are just going to be in parallel. So let's do R20. Let me make this a little bit neater. I'm trying to make it compact. 21 would be 20, 22. 21 is this one here, which is across 7 and 8. So that's 22, that's 23. Very cost-sensitive design, which is funny because I bet you that card was really expensive when it came out. I'm sure someone here could go look up the price if they were so inclined. But it must have been expensive. $20, $22. And so that's that set of resistors. Go ahead and wire it up. Okay, and then we've got the capacitors afterwards. So that's probably all part of the joystick port connections. And then I think the other two resistors might be for the MIDI function. All right, so we need to get some capacitors in there. So let's go ahead and do that next. Oh, that must be the input, because that's probably an input pull-up. Interesting. Okay, so next one we have 29, 30, 31, and 32. These are all going to be the same value, which is great because one of them is damaged. So I can just measure one of the remaining ones and then just put that cap in, call it good. C31. Okay, so we start out with C29, pin 2 goes up to R20. Zoop. Next one would be C31. And then C32. And then C29. Let's see if I got it right. I sure did. And then these all go to vias. So some of them are shared, but I bet you these are all going to ground. Okay, so that is our joystick port with the exception of C36 and C38 and these guys here. So I should probably do these next. So we made it out to C32. And what's the next one? C33 is going to be on the bottom here, and that goes to R17. There's a good chance this has the same value as well, but we'll see. And then C35 goes to pin 14. How about C34? Where does C34 go? That's this guy here. And that goes to R18. Cool, cool. Okay. Yeah, it looks like the next two go to pin 14 and pin 7, and that would be 35 and 37. So let's do 35 next. And 35 is pin 14. Go ahead and save that, pull that in. Okay. Oh, I need to move the designator. So that's in the correct spot. So that's C35. And then I guess C36 is up here on pin 10. That'll be interesting. I'm going to make a little bit more room here. C36, and then C37 to pin 7. Great. $37. Yeah, these are all EMI filtering caps, so these will be easy to replace. Although I guess some of these could be the charging caps for the joystick port functionality. So I should measure the ones that are already there, just in case. C38, look at that. Interesting. Yeah, I have a funny feeling that pins 1 and pins 9 are plus 5 volts. And that's just the filter. That normally would have gone to the joystick to provide power to the buttons. But a lot of those MIDI cables that you could buy that would adapt these to the standard MIDI cable had active transceivers in them, and those needed 5 volts, and so they would just pick them off of these two pins here. All right, so the next one is C38 on pin 2. Oh, that's way up there. Okay. I guess I need a little bit more room again. Okay, let's throw those in here. So that's C38. I'll save that, and then let's do this guy here. Oh, look at that. What happened there? Connected. All right, so I'm sure all these pin 1s just go to ground, so at some point I'll just figure that out. But for now, we've got all those connections in there. I guess I could start running traces out to pins. Oh, forgot something. So there's our joystick port. C29, that's not right. So when I'm done with this, it'll just be test point markings, and that'll make it easy to put these in. But yeah, might as well start running some of these traces. And then this one comes from here. Another test point. A little hard to tell where that one is coming from, but I think it's here. And that one. Another test point. So you can also see these vias here. I don't know what connection they go to, but yeah. I don't know where this one's going. That's weird. Puzzling. I mean, this one's kind of obvious, but I don't know where this one's going. I guess I assumed that it went across here, but then there's no room for this trace. So I don't know what the story is there, unless there's something I missed. Let me look at the actual physical board, which I have in front of me. Well, that's puzzling. I can't tell on that board either. Let's see if we can spot any vias. Oh, it's underneath. That's sneaky. Also bad for design rules. I just realized something terrible. I forgot to change my design constraints for clearance. I think that should be 10. And these are all going to fail. Actually, you know what? I need to do some math. It's not 10. So this would be 20 minus 12, so that would be 8. That makes more sense. Let's do 8 and 10. I think it's the grid, maybe. No, maybe not. Seems to be okay. I'm sure it'll throw a bunch of DRC errors later, but that's okay because no one is ever going to fab this board. Nobody. Actually, that's not true. Someone might have a really trashed Gravis Ultrasound. Or, yeah, like really trashed, and then they've got the main chip and they just want to transplant it. I could definitely see that happening. I don't know where that one's coming from, so I'll probably have to figure that one out. Look at that. We have a small percentage of the board done. It's going quickly, isn't it? Oh, it's Jay Haluska. Welcome. Okay, so this is just this pin here. And we'll just go over here, pop up through a via, and then continue on. And then we've got this trace. Dun, 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 dun. We'll just come through here. Nice. That is a good chunk of our joystick port. And since I know the pinout, because it's standardized, I could actually start giving these net names at some point. So that'll be fun. Yeah, so you can see these all just go up into that custom chip. That's very funny. So presumably this chip does everything a sound card needs to do. Fully integrated, no external components except for some buffers and stuff. And on to the next one. Yep, it's just routing, just a bunch of traces. But this is also useful because I will need to check continuity. A bunch of these traces got thrashed by whoever worked on this board last. Oh, I don't like this. I'm just going to have to move this up a little bit. Yeah, that footprint's slightly different. I don't like that. That is right on the edge. Call it good for now. These are just voltage regulators that they use to make the low noise supplies that power the op amps, I think. So I think there's like a plus and minus 8 volts, which probably runs the op amps. And there's also a 5-volt regulator on there for some reason. And I suspect that is powered off of the plus and minus 12-volt rails that every PC seems to have. Although, interestingly enough, they got rid of the minus 5-volt supply at some point because that was used for like old-style memory chips, which went away after the earliest PCs. And so they kept the minus 5-volt rail for a while for compatibility, and then at some point it just completely vanished. So cards that use that voltage rail won't work in later PCs, but I think that was pretty uncommon. The 12 volt rails stuck around for a long time because they were used, well, the minus 12 volt rail was used for RS-232 level shifters. And that would have been before the things like the Max 232 came out. So instead, they used the MC 1488 and 1489 line drivers and receivers, and those needed plus or minus 12 volts. The other thing I can do here is figure out which pins are ground and the connections of those internal planes. So that'll be handy at some point. Yeah, look at that. And then we'll go back to the top layer again and get the rest of these sorted. Yeah, they're just going to go pads to the main chip here. And I'll need to figure out what footprint to use for that and what symbol. So eventually that'll be a custom symbol. But for now, I might as well just use like a giant connector so I can start wiring up nets. And then once I know what the pinout is, then I can create a custom symbol for it. It's kind of weird because it almost feels like having some big SoC. That's kind of how you would wire up a modern one, right? So you've got sort of this giant fuzzball where all the wires go into it. And then the only thing external would be like maybe a little bit of buffering and the RAM chips and some other random crap. So that's fun. Yeah, this is all joystick stuff. It's interesting how they're in different spots. My assumption is that joystick is like up in this corner here, and MIDI is in the other corner. But it's probably something dumb, like they just routed the UART wires because they need the MIDI level transceivers. The opto-isolators are typically in the adapter cable that you plug in, and then it's just like a 5 volt logic level signal going out. That goes up here. Yeah, that's some big quad flat pack. Yeah, I mean, I know it's a 160 pin QFP, but I need to figure out the lead pitch and dimensions because their footprint's kind of weird, but we'll figure that out later. All right, so that's basically the joystick port. But I'm also just going in order with the capacitors and resistors and such. What's next? Next one is R24. Let's see if we can figure out where that is. So I'm just going to look around here and see what there is to be seen. R28, R30, 29, 27, R27, huh? 34. I'm trying to go roughly in order. 32. Yeah, some of this board is in pretty rough shape. 34, 35, 36, 37, 24. Here's our 24. That goes to 24 and 25 and 26. Those could be data lines because that's on the IDE CD-ROM. These are all 10Ks. So I'm just going to place them, but I'm not going to route them. So that's 3.3K on both of those and then 10K here. wonder if any of the others had markings that were visible. R36 did. This one looks like a 10K. R19 is a 10K. I bet you that's a pull-up. That's probably the receive input for the MIDI port. And then some of these guys might... Oh, I can just look at the physical board since I have it here. R18 is 1K. R17 is also 1K. Yeah, so those will be protection resistors because back in the day, everyone hot plugged their joystick port. Okay. And then the rest I don't know because that resistor array is missing. So at some point I'll have to figure that out. Okay, so 24 and then 25 and 26, those are both going to be 3.3K. Yeah, these might be strapping resistors to configure the chip. That would be my guess, because not all of these data lines or whatever they are have those resistors on them. So there's also a memory chip that goes here. I'm not sure what it's doing, but maybe it's the IDE buffer. And this would be sample RAM here, and then that would be the optional sample RAM. Although actually these are connected together, so there might be some shared functionality there. But they don't have too many of these resistors, so I suspect those could be configuration straps. And we have another 8-pin resistor array, but I actually do have that one physically, so I can measure it. But actually I think it's a 10K, I just don't know if it's bus or individual resistors. And then this is JPR 13 or 18, so presumably this is a configuration jumper. So we'll have to figure that out at some point. All right, so that's R26. The next one will be R27, and that'll be on this other op amp here. So I think it's time to get that going. I'm going to rearrange things a little bit on the schematic. All right, so let's see how this works. So pin 1, might as well do this one first. I think that's the feedback resistor. Yeah, pin 1 to pin 2. And then presumably there's a capacitor, C64. Oh, we're up there already, huh? C63. Yeah, what's the next capacitor we need to do? So these filter caps were up to C38. So presumably they did all the bypass capacitors and then they switched over. So I guess I'll just have to start again at C64 and then I'll do the ones in between. It's fine. Doesn't really matter. So that is going to be C64. And we don't know what those values are, but this is a 20K. So that's useful. Oh, I copied the wrong resistor. Funny. Let's go back to an 0805. Let's try that again. There's our parts. And then C65 goes on pin 3. C65, C66, C67. And then we've got R31 here. Let's do R28 on pin 3 to ground. I'm presuming. Might not be. But these are all shorted together, so... Oh, actually, microphone power. I don't know. That's a good question. All right, so that's that. C96. And then we have R29. That seems to be in series, which is odd. That might have been tacked on later because it's got such a high value. So you can do a little PCB forensics to figure out like how they designed it. So that'll be R28. Maybe. Oh, I did this backwards. That's more like it. And these two shared connections, I'm not sure where those go, but we'll figure that out. Pin 3 goes to C66. And then the other capacitor is C65. Oops. C65. Yeah, this might be the mic bias power supply or buffer or something like that. Not sure how they're doing this, but we'll find out. Okay, so pin 2 here goes to pin 3. And then the other pin goes to C65. That'll go here. J1 mic in. Time to put in J1 mic in. So this will be the T connection. Oh, there's our connector. Oh, I just realized that should be J1. Let's fix that and reload it. There's J1. Let's go ahead and hook up the wires. And then the R connection goes way over here. That's a puzzle. Where does that go? Looks like it goes to C96, but does it go anywhere else, I wonder? Time to bring out the multimeter. I will be right back. I'm back with a multimeter. It'll make a beeping sound. Hopefully it doesn't bother you too much. But let's go ahead and figure this out. Huh, that's weird. It only goes to C96. That's bizarre. Not what I expected, but I'm sure it'll all become clear once that whole circuit gets buzzed out. Okay. Those two are tied together and do go to a via, presumably to some power connection. That's really weird. Yeah, that's very bizarre. I don't really understand what's going on there. Well, move on to the next one. So that's C65. Let's run these wires here with the correct size. Oh, there's another cap here. Or is that a resistor? R31. No, there's an R29 I need to place somewhere. That's a 2K. And that goes where? Where does that go? That goes here. Yeah, so far this is kind of a mysterious schematic, but we'll see. Okay, and then we've got R31. Where's R30? Oh, down here. Not sure what's going on with that. That looks like it might be a supply rail. So there's probably something on the other side of the board. Yeah, so that goes to pin 5. So pin 5 has a pull-up. Guess we'll see what that looks like. That is a 10K. R30. And then C63. Yeah, this poor board is trashed. I think the electrolytics all leaked. And when I found it, it also had a bunch of replacements that were badly installed. So who knows what's going on with that. Man, why did it do that? That's like my least favorite KiCad feature. It just automatically makes birds' beaks, which is very annoying. And that's a pull-up to something, which we'll figure out later. R30, and then R31 is over here. That was missing, so I don't know what that value was, but that goes from pin 2 to something. I'm not sure where the other end goes, but it might be a supply rail. Well, now we know how this capacitor is connected. That also goes to pin 1. And that is C67 plus terminal. Go ahead and wire that in. Oh, U16, that should be up here. Wait a minute. I got the polarity wrong. Let's try that for size. And then this goes to the mysterious diode array here, which is presumably between power and ground. Curiouser and curiouser. Let's get some diodes in here. So it looks like D1 points away, so that's on the upper side. We don't know what that is. What's the footprint? Hard to say. Might be one of those cylindrical glass diodes. Maybe. Actually, it's probably SOD 123. Let's try that one anyway, see if it fits. Pull that in, and let's see if it fits. Oh, look at that, perfect fit. Let's just get the polarity correct. Get that wired up and get the next diode in. There's D2. And another test point. I really do need to get those test points in eventually. And then presumably this goes off to a pin on the chip. And then there's also this microphone power switch that we need to hook up at some point. Man, that is weird. All right. Where does that go? That goes to this resistor. So it looks like on is 1 and 2. Let's get a 3-pin switch with a mounting hole. SW, double pull, double throw, ground. No, that's not right. I want single pull, double throw. The problem is it also needs to have these mounting holes here. All right, I'm taking too long. I'm just going to throw this in and we'll call it good. Pin 2 is the common, pin 1 is that resistor. And then I need to find the footprint for this thing. What's the pin pitch? 80, 70, 80 mils. Let's see what I got here. Switch. Oh, these are both terrible. Oh, I think this is my own switch library. That's funny. I don't remember what the name of the library is for that. I don't think it's connector. Button switch. All right, let's see if they have anything that looks like it's an approximate fit, and then we'll just grab that and call it good. Nope, 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 nope. These are all dips. They got to have all the different dip switches. Nope. Bunch of push switches, single pole, single. Nope, slide switch. Here we go. Oh, that one's pretty close. All right, we'll call this good, see if it looks good. It'll probably be huge. Oh, no, it's actually about right. Look at that. That's pretty close. Just call that good for now. Does not have a designator. That's okay. And then pin 2 goes back into pin 6 and pin 7. Interesting. So this is some kind of a buffer. Interesting. Yeah, so I think they're just buffering bias voltage. I think that's what they're doing here. And then that bias voltage comes from this resistor and this capacitor. So presumably that has a nice little RC time constant so that it comes up nice and slow, so you don't get any pops or anything like that. And do we go anywhere else here? No, it doesn't look like it. So that'll be microphone power. Oh, this is called something else. That would be mic in. Yeah, that actually makes sense. So there's a 2K resistor and then a bypass cap, but then for some reason there's another little capacitor on the ring. That might be to support other kinds of microphones. Who knows? So that's kind of weird. And then there's R31. I don't know where the other end of that goes, but presumably it's bias or ground. Actually, that would make sense if it's ground, because then that would be a non-inverting op-amp circuit. And then the output of that goes through the capacitor for coupling. And then it goes through these two diodes, which clamp it so that we don't overdrive the input on the chip over here. So let's just continue routing this. And then presumably this just goes directly into the chip. Yep, sure enough, look at that. Just goes directly into a pin, as expected. So that means this thing's got analog to digital converters built in. Wild. I'm going to catch up with a scroll back real quick. Let's see. Goal is to document for historical purposes or trying to make a modern replacement. Mainly documenting this for historical purposes and repair purposes, because this card was loaned to me to repair, and so I do need to fix it at some point. How much you learn, not necessarily about reverse engineering. Random anecdotes. Yes, random anecdotes is where it's at. I don't know what's going on there. We'll have to figure that out. Also, there's a jumper, JP9. I don't know what that thing does, but we'll get to figure that one out too. But it looks like we have most of the op-amp stuff figured out. There's some power bypass capacitors that we should probably figure out. So probably not dissimilar to the other op-amp. So we might as well go and do those next. I guess I should buzz out which pins those go to because, oh, nope, that's easy. Pin 4 goes to whatever that thing is, C61 and C62. And then presumably C68 and C69 go to pin 8, so we can do that. Pull in these bypass caps. And I do need to figure out what the power and ground planes look like eventually. 60... Surprised nobody's laughing at C69, but honestly, you should have been laughing at C67. Okay, here's C68. I'll throw that over here. C61. Oh, these are reversed. Yeah. Save that, start throwing in a couple of traces. We got a 20 mil trace here. Oh, I didn't even connect those. Let's do 40. I got it wrong. Flip it around. That might be 50. And that looks like a via. Anyway, that goes somewhere. That'll be 40. And 50. Presumably these go off to those 7808s. All right, so we know the op amps both have the same power supply. So that's cool. And that also happens to be C22. I haven't figured out how to connect that one yet. All right, so the op amps do indeed share a power rail, so that's cool. And that just so happens to be this side of the ferrite bead, which goes over here, and that is 7808. So that will be a plus 8 volt rail. I guess I should just add that now. Plus 8 volts. There's our connections. Keeps tripping me up seeing red silk screen on the traces or solder mask on the traces, because then I think I'm on the top side of the board still. So that's kind of funny. And that's that. Top side of the board, 40 mil trace to this bypass cap. And then one of these is probably the negative rail. That might be ground. There's a jumper wire. So that's fun. And that goes over here, which is another ferrite bead. And I have not wired that network up yet, because I don't know where it goes. Yeah, I might have to ohm that one out. I'm curious about that negative rail, though. So let's see what ferrite bead that comes from. Oh, that's this guy here. Oh, I'm 40 mil. That should be 50 mils. Let's try that again. So this is probably minus 8 volts. So let's see where this takes us. Ah. That takes us over here. So that is a negative 8 volt rail. Let's put that in. Minus 8 volts. Oh, no, wait, that's 5 volts. Sorry. I think that should be a 5 volt analog. So let's do 5 VA. Okay, that makes more sense. Okay, actually that is going to be a different size. Maybe. No, I think I had it right. Okay. That'll be 40 mil going out here. That goes to D1. And that disappears. Presumably there's a plane layer that it connects to. Alright, so this is probably negative 8 volts then. So I'm just going to go ahead and take the liberty of installing those connections for minus 8 volts. And we'll see how that goes. Yeah, I think we're already better off than the Sound Blaster as far as audio quality is concerned. That goes to a via. I said that goes to a via. That also goes there. Okay. Oh, look at that. And that goes to this ferrite bead. That makes sense. So presumably they're using the ferrite beads to try and filter any supply noise, but they don't have a capacitor on the other side of it, which is an interesting choice. So presumably this pore here connects to the negative output of the 7908, which is going to be this pad over here. So I guess there's probably a copper plane underneath here that I can't see, or just a wire. Okay, that's funny. So we just have a little wire that goes here and then here. Oh, I got to update my net. Let's move that over here. Just hooking up wires. Don't mind me. Okay, and then that 7908. Okay, that's better. Okay. That looks right. Let's go ahead and add a wire here. And that's that. So that's our power all wired up. So I pretty much have this whole questionable section done. There's some component values I need to pick off. So I'll have to take care of that at some point, but that's in pretty good shape. A bunch of crap over here, and some of that stuff I'll have to figure out. And then, of course, all of the digital. So I'll need to get a card edge connection in here and then start running all of those wires. But yeah, we're getting there. We've got a lot of the analog. Let's grab this wire here since we're in here. Well, that was easy. Okay. So that's basically all that analog. I guess I could do some of this connector wiring here. So let's try that. And actually, before I get too involved with that, I'm going to go ahead and take a quick break. And so I will park you on my standby screen, and I'll be back in maybe 10 minutes or so. So enjoy the break, and I will see you in a bit. And we're back. Let's see, where were we? Oh yeah, running some wires. Let's just keep doing that. C11, I wonder where that one goes. And then there's all of this nonsense here. And that goes over here. Oh, that's where that jumper goes. We'll have to figure that out. That's a test point, so I can ignore that for now. We'll have to follow this trace. It goes into the big chip. Look at that. Fascinating. And then presumably the same thing with this guy. Yeah, it looks like it. This is the CD audio input, by the way, which appears to have like 0 buffering, so that's kind of fun. Man, this chip really is all in one. All right, so there are some resistors and capacitors, but yeah, it pretty much just goes straight in. Yeah, that might go to ground. So it's a resistor divider and then a series coupling capacitor. Interesting. Okay, how about JP9? Whatever that is. Might as well throw that in. And I don't know what that does, so we'll just leave that alone. Let me give that a footprint. And I'll just use a pin header for this one. Vertical. Oh, there it is. It's kind of huge looking. And so pin 1 of that goes up and around. Wrong trace size. Let's go with the 12 mil for now. I think this is probably 15, but who cares? And that goes all the way through. Actually, yeah, that's a good question. How wide is this trace? That's 12. This might be 10. Yeah, so they do have a 10 mil trace. Good to know. Oh, I gotta go back to the right grid. Where does that go? I don't know. Doesn't seem to go anywhere. So that's fun. And then on this side we go to R34 and R47. And I don't know what value those are. Do I? Let me check. Oh, they're marked here. They're both 10K. So that's a 10K. That's a 10K. And I think they're tied together. There we go. R34. R47. That kind of looks like a resistor divider. And then we have C74 and C88. But C88 looks like a bypass cap. I don't see it connect to any of this stuff here. But then C74 also goes to R34. So we'll have to tack that on too. C74. A lot of the stuff I can measure, especially since I removed the chip in the circuit and there's nothing else on that net. Oh, that actually goes to the other end. So that might be another bypass cap. Well, who knows? That looks like a 20 mil trace, which, yeah, that could be bypass. Oh, look at that. So it goes through and then up to a via over here, which is interesting. So let's take a 12 mil and we'll just sort of sketch that in. That goes to a plane of some kind. So that just might be a bypass cap in that case. Yeah. Huh, I wonder where this trace goes. You know what, this looks like it's 10 mil. Yeah, that's 10 mil. Okay. Wow, this goes all over. Through here. That goes to a 93C66. Well, that's interesting. All the way over here to this pin of R47. I should probably put in that 9366 and then see what this connection actually does. That might be like a write protect jumper or something, who knows. Why would this have a EEPROM on there? That's kind of interesting. And let's give that the dip footprint. I'll ignore the surface mount footprint for now. That goes to pin 1. Interesting. That is the chip select line because this is a SPI or SPI serial EEPROM. Oh, I gave it the wrong ID. Hold on, let's fix that. U6. Yeah, look at that. That's very interesting. So that is the chip select line. And that goes off to a resistor, which goes to a jumper that goes somewhere else. And then there's another resistor. And they're both 10K. So that's a little mysterious. Where's U5 anyway? I think that's one of these chips here. 9. And this one wasn't stuffed. I don't know what this chip is, but it was not installed. But the crystals, I think, were installed. I'll have to go and dig up a reference photo and take a look at that. Actually, maybe it's time to start thinking about putting in the big chip here, U7. Yikes, it's almost 4 a.m. Oh my, you better get off to bed. Sounds great when you manage to get it to work. Yeah, exactly. Okay, so this looks like it's got 160 pins. And what is the pin pitch? Let's go back to 1 mil here. 10. 25.5 mils. That sounds like this is metric. Yeah, 25.4 mils. Wait a minute. No. It's not. Oh, what is the pin pitch? Let's see. It could be 25 mils. That's 10. That's 260. That doesn't make any sense. But it's not metric, because otherwise that would be a nice number. I guess it could be 0.65. Yeah, it's probably 0.65. Let's take a look and see. Yeah, that looks like 0.65. How about the other direction? Yeah, okay, so I could do 10 of these and then divide by 10. That says it's 5.8 millimeters, so that's not right either. 230 mils. Well, that's maddening. I think my scanner's calibration might be off. Yeah, 254, 255 mils, or 0.65. All right, well, let's see if that matches up with a package that I actually have here. I wonder if I have anything that's got 80 pins. Oh, that's 80 pins. I want something that's 160. Oh, I might have to be stuck making my own symbol. No, there's a 60A and 60B, but that's not going to work. I just want something that's ordered. 2 by 60. That's weird. I mean, that definitely has 180 pins. Or, sorry, 120 pins. But it looks like I'll have to create a custom symbol to get that in here. But let's see if I actually have a footprint that fits. So you can actually place the footprint directly. Where would that be? Not inductor, package, quad flat pack. So there's 144. Oh, there's 160. And that's a 0.5 millimeter pitch. So I'm probably gonna have to create a custom footprint too. Rats, I was feeling lazy. Yeah, you can see this is wrong. Just type in 160 and see what shows up. There's a PQFP. Oh, that might be the right one. Ooh, that's close. Yeah, I could probably use this one. So I just need to get pin 1 correct. Yeah, something like this. $63.60, $32.90. Yeah, seems reasonably close. Their pad size or their pad shape is different, but I think this is pretty representative of the package, so I'll just leave that here for now. But I'm going to need to create a couple of, I'm going to have to create a symbol here to represent this device. I could do it in sections, I guess. That probably wouldn't be a bad way to go. And so what we have here are, looks like joystick pins. And I've got some CD audio in, and then I've got UART on 106 and 107. And then presumably a bunch of these pins are like ground and stuff like that, so I'll have to figure that out. Let's pull up the symbol editor. I think it's relatively easy to add extra symbols, but maybe I'll just do it as one for now. Let's do a project library for this one. We'll call that one Amadeus. I guess they must have been fans of the movie. And let's throw in a couple of pins. Oh, actually, you know what that reminds me? That would be 42. Five, 46, 47, 48, 49. And I'll just save that, and then let me edit the footprint here. Sorry, you can't see this. But we're going to look for a 160 pin package, PQFP. AM78C20. And I'll drop that on the schematic somewhere. And that will be U7. Go ahead and save that, and then update this guy. I gotta do this nonsense all over again. 3290. All right. That's probably more accurate. Great, save that. Actually, let's put this up here. And then I guess I can start figuring out what these joystick pins are. So I need to go and look up the PC joystick pinout. And then start throwing in some net names. Good, all pinouts has it, of course. So 1 and 9 is indeed plus 5 volts of DC. Pin 2 is button 1. Pin 10 is button 3. Pin 3 is X1. Actually, let me do that out here. Apologize that you can't see that. 4 and 5 is ground, sure, whatever. 6 is Y1. X1, Y1, and then we've got B2 on pin 7. And then X2 is on pin 11. And then Y2 is on 13. And then B4 is on 14. Great. And then it looks like 15 is, they're calling it plus 5 volts DC, but that's MIDI in. So let's do that. MIDI in on 15. And then MIDI out would be pin 12. That's interesting that it's got a pull-up resistor on it. MIDI in and MIDI out relative to what? Well, that's puzzling. Okay, so we'll update it, and that'll propagate the net name all the way up to the pin. And now we can see what these pins actually have to be called. So we have X1, Y1, X2, Y2, button 1, button 2, button 3, button 4. Wow. Nice linear order. So now I can go ahead and fix that on my symbol. So 49. Joystick Y1, X2, Y2. Button 3, button 4. Save that. And I think that'll also update the name of the pin here. Yeah. So now you can see that. So that's all lined up. Yeah, that'll be some work getting all that lined up, but I think we're in good shape here. And then at some point I need to get my ISA card edge in here and start naming those nets and getting this buffer connected and so on and so forth. Let's see how folks are doing. Amadeus. Choose to interpret that as they were fans of the Austrian singer-rapper Falco. Do you mean Austrian or Australian? All right. So let's get that edge connector in. I think there's a card edge here. ISA. Bus ISA 16-bit. I think I have my own version, which is superior to the one that comes with KiCad. So let's go ahead and throw that one in. I don't think that should be called J4, though. It might be all right. See if there are any other jumpers here. So that's P1, and then we've got J1, 2, and 3. And then some test points. And then these are all JP, so like JP8, JP7. So I think we're okay here. Yeah, that'll be fine. Did I give it a footprint? I did not. Bus, 16-bit. That should just match up. Let's pull that in. Oh, look at that. It even shows where the card edge is supposed to go. No, one of these will work. Yeah, so the dimensions are off a little bit. Interesting. That's fine though. Now I know what these pins do. So these are all the data bus pins, which means that I can now begin wiring up this 74LS245, which is going to be U11. So let's get that out of the way, and then I'm going to start wiring up a data bus. Oh, actually, I should just do DB0, and then let's do it this way. Okay, so that's that, and then we need a LS245. That will be U11, and we'll need to give that a footprint. That's SOIC, I think. Package, SO. Is that the wide or the narrow? I think that might be the narrow package. Let's see if that worked. Here's our part. Looks about right. And there's our pin 1 marker. And of course this is the wrong width, so maybe it is the wide package. It's not SOP, it's probably SOIC, but it does need to have the correct pitch. Let's try the Infineon one. That one's got narrower pads, and I'm a little worried about running out of space on the inside of this layout here. Oh, that's about right. Let me try one more experiment. So that's the Infineon SOIC 12.8, huh? These have longer pads. Let's try this one. Nah, that's more like it. Okay. Just realized my grid is still set wrong. But fortunately that worked. Okay, now we can figure out what pins go to what. So this is DB7, 6, 5, 4, 3, 2, 1, and 0. So it's just in order. And then that'll presumably go to some internal data bus. Oh, this actually wraps through and goes directly here. So that buffer goes somewhere else. Presumably to the IDE port. So that's kind of interesting. So we'll need to figure out what's the story with that. Yeah, these go up here and then cut around and then come up and over. And yeah, sure enough, these are IDE. So I'm going to give these a new name. So this will be IDB. There we go. So now these have their proper names, and we can actually start routing some of the stuff here. So I think these are probably all 10 mil. Yeah, it looks like it. That goes there. Yeah, look at that. So then I can start routing the wires up here. I think these, are these 12 or 10? Let's check. Could be 12. Those are probably 10, and these are 12. So that's fun. And that's IO channel check. That probably just gets plumbed directly out to the IDE connector. So I'll need to go and wire that one up too. Mm-hmm. All right, we'll just run a bunch of wires. Might actually be more interesting to start filling in the schematic instead of just running endless data buses, because I can do this on my own time. Yeah, that looks about right. Now I'm debating if I should just fabricate a new board and then swap the components over. But then I'd end up with a bunch of spare boards that have no custom chip to plug into them. So it might be better just to repair the original, because then it's an original and it's not one that's had the entire board replaced. Let's hide the bottom there. That makes it easier. So let's go up here. And of course, I'm sure all of these data bus pins go directly underneath the audio signals, as is tradition for sound cards. And then these will go on the bottom layer. And get to route these up here. Are these 12 or 10? I think they're still 12. Ooh, just scraping by there. Might have to change to a different grid for that one. Oh, no, there we go. And just come up through here. Get a couple of these guys. Wait till I have to get to the address lines. Actually, just kidding. There's not that many of them. But there are a bunch of lines that go out to the SIM modules. So that'll take a little while to burn through, but on the other hand, I can then check continuity on this board to make sure that I've fixed all the wires. I'll have to probably shift all these around a little bit because that silly header has a square pin instead of a round pin. So that throws off everything. Ooh. That's not right. I need to shift that over. I think at some points I might have to start using a 5mm grid. Oop, that was right. Yeah. Not sure what happened there. But we're going to have to shift all of the stuff down. Actually, it's easier to just, well, no easy way to do this. Man, that is really annoying. I don't know why it keeps doing that. All I want to do is just drag it without leaving these little tails at the end. But it insists on putting them there so that I then immediately have to delete them. All right, whatever. I'll just route around it. I wonder how far back I can shift this. Not that far. All right, so there's probably enough room for the via. Okay. Let's go to the top layer and continue. Probably need to get the IDE connector added as well. I'll do that a little later, I think. All right, that'll go out here. It's kind of like watching the grass grow. It's definitely going to be more interesting getting component values into the audio section, which I will do as soon as I run these last couple of wires. All right, that's our data bus. This also starts to make it really obvious when I've got traces that I haven't connected yet. So you'll definitely see them show up. Okay, so let's go ahead and save this, and then I'll show you the schematic so far. So there's our ISA bus. There are some of our local regulators. I haven't hooked up grounds yet. These capacitor values are not known. This is our joystick input that we spent so much time on. And then up here we've got the, looks like the line in, the CD audio in, and then here are the amplifiers So the line out amplifier and the microphone input. So let's focus in on those and see where that takes us. So maybe we start with R9. And I'm going to go to Mastodon because somebody sent me a screenshot. And so R9, I wonder if I can even see it in their revision. Open image, a new tab. Let's try that. Oh yeah, much better. Looks like it's a 10K. So that's cool. R10, that is 20K. No wonder somebody robbed all the parts off this board. And then presumably this is the same. R14, also 10K. And then R13 is also 20K. Well, these are jelly bean parts. These will be easy to fix. Then we do have R15. Looks like that's 33, or is it? Yeah, 33 ohms. The resistor code is 330, so that would be a 33 with 0 zeros, which is just 33 ohms. And then how about R11? That is 47K. And then I'm sure these are just generic coupling caps. They're probably 1 microfarad. And then I think these are just EMI filters, probably in the picofarad range. R12 is going to be another 47K, I would imagine. Yeah, 47K. That's pretty much that for the line out. Next up we have the input here. So that's the microphone input. This is the bias connection here. So 2K is pretty standard for that. And then this is going to be buffering 5VA with this little RC circuit. So that's extremely simple. 20K, so it's R31 that we need to figure out. So that's way up at the top of the board here. And of course I can't read it that well. 391 could be 390 ohms. And then the other one is 20K. Let me go to Retro Web and see if they've got some good pictures. Can I zoom in? I cannot. Let's try another picture. Oh, this one I can zoom in. 391, so that is indeed 390 ohms. And then the other one is 20K, so presumably this has a lot of gain. I can actually calculate what that is very easily. So that would be, what is that, 20 divided by 390. That would be a gain of 52. That's quite high. And looks like the diodes are actually MELF diodes, which are the glass ones. So that's cute. I'm sure they're also jelly bean parts, probably nothing special at all. Let's see what else we have. R27, R28. R28 is not really readable, but that looks like 20K. R29 is 2K. That's right. That's the bias resistor. And then we already got R31, R27, 20K. And R30 is 10K. Yeah, that's 10K. And then there's a bunch of 5.1K resistors that I think we already took care of over here. R7 and R8. R3 and R4 are also the same. And then R1 and R2, also the same. So it's these capacitors that I don't know because they are not marked, as is tradition. Yeah, so that kind of makes sense. So the line in and the CD go through these dividers. Yeah, we already got R10, R9, R14, R13, R16, yeah, also 330, so we already got all of that. R36 is an odd value. Let's see if that's in here. Oh, I haven't put that in yet. R19, 10K, R32. I guess I have not installed that one yet. So it shows the resistor array, and it shows R17 and R18, but the others are no stuff, so these guys are DNI. Do not install. And then we've got some ferrite beads, which I'll probably measure at some point, but the big one is I don't know what that resistor array value is, so I'll need to figure that out. So presumably someone has a photo of this thing at an oblique angle, and I might get lucky. So it's fine. Anything else I can see here? I think I pretty much got it for now. I think the others I already had all the values of. Yeah, so I think this does explain why a lot of these parts were gone, is that someone was using this as a parts unit, and they were just desoldering parts and using it for some other board. I think that's what was going on. Let's see if anything else is a question mark that's not a capacitor. Yeah, I think I got pretty much all the resistors now. So that's important. Yeah, that looks good. Cool. All right. Well, I think this is a good stopping point. I've made a lot of really good progress. Let me catch up and see if there are any questions. Any questions, folks? Put them in the chat now. Otherwise, forever hold your peace. Well, at least until next time. So this is our board so far. We've got all the analog and a little bit of the digital, and there's a lot more digital to go. So that will be some pretty boring stuff to dig through. But at this point, I know pretty much enough to get the repair started on the card, just to get components reinstalled over here where they were missing, and then presumably get a list of some parts to go order. But it looks like we're in pretty good shape there. And then, of course, I got to figure out what that resistor array is. But I think we're well on our way. No other questions, so I'm going to go ahead and wrap things up. Thank you all for tuning in, and I will see you next time. Enjoy your evening and or morning. Bye.